How time unfolds quantum physics, consciousness, and the flow of reality, key points. Newton's laws of physics don't work at the atomic level, which led to the discovery of quantum mechanics. Quantum particles exist in many states until observed, then at some point they somehow choose one. Time unfolds moment to moment as the most probable next moment through quantum mechanics. Consciousness may influence which moments of reality become real from all of the quantum choices. Have you ever stopped to wonder how time really works? How we move from one moment to the next? Living life as a steady stream of now after now? This has been an unanswered question for centuries. And while scientists still don't have a final answer, what we've learned over the past 100 years has completely changed how we understand it. Until the early 20th century, scientists believed they had most of the puzzle solved. To them, the world behaved like a perfect machine, predictable, logical, and orderly. That view came from Isaac Newton, a scientist in the 1600s who explained how objects move. His laws said that if you know where something is and how fast it's going, you can calculate exactly where it will be later. This way of thinking worked brilliantly for everyday things, like falling apples or orbiting planets, and guided science for more than 200 years. But everything changed when scientists started looking much closer, down to the level of atoms and smaller. That's when they discovered that Newton's rules no longer worked. Particles behaved in strange and unpredictable ways. It wasn't a small problem. It meant the whole system of understanding the universe needed to be rethought. The first big clue came from Max Planck, a German physicist who's now known as the father of quantum theory. Around 1900, he was studying how hot objects give off light. Why, for example, metal glows red, then white as it heats up. Classical theories couldn't explain what was happening. Planck made a bold guess. Maybe energy doesn't flow continuously like water, but in tiny chunks, which he called quanta. It was a strange idea, but it fit the data perfectly, even though Planck himself didn't yet understand what it really meant. A few years later, Albert Einstein took things further. He showed that light could behave both like a wave, spreading out like ripples on a pond, and like a particle, a kind of energy bullet. These discoveries led to a whole new theory, quantum mechanics.